Hey everyone, and welcome to This Explainer. Today, we're tackling a concept that is basically a software developer's absolute best friend. Well, right up until it suddenly isn't. We're talking about greedy algorithms. Look, everyone loves them. They're lightning fast to execute, and the code you end up with, usually beautifully clean. But there is a massive catch here. How do you actually know when your fast, clean code is, correct? In this explainer, we're going to break down exactly how to verify when it's absolutely safe to be greedy and when it's just a trap.
Okay, let's dive into this with the standard definition. A greedy algorithm makes the locally optimal choice at each step, hoping it leads to a globally optimal solution. Now read that carefully. Did you catch the absolutely most dangerous word in computer science? It's right there, hoping. In programming, hope is definitely not a strategy. Making the best choice right now, in this exact micro moment, doesn't always mean you win the game in the end. Our entire goal today is to completely eliminate that word hoping from your vocabulary.
All right, Section 1, a real-life dilemma. Let's talk about booking the boardroom. To really ground this concept, I want you to imagine you're the office manager for a crazy busy startup. How do you schedule the absolute maximum number of meetings in a single conference room? Imagine you've got this massive pile of meeting requests for the day. Some are, quick 15-minute syncs. Others are these huge 3-hour marathon brainstorming sessions. And naturally, a ton of them overlap. You want to fit as many distinct meetings into that room as humanly possible. So, what's your strategy? Take a second. How would you physically sort that pile of requests? Well, if you guessed that you should look at when the meetings finish, you absolutely nailed it. The greedy solution here is to sort all those meetings by their end time and just always pick the one that ends the earliest. And why does that work? Because the earlier a meeting ends, the more time you free up for the rest of the meetings. It's incredibly intuitive, right? In computer science, this is known as the classic interval scheduling problem. You just made a local choice, picking the quickest to finish meeting right now, and it miraculously built the perfect global schedule for the entire day. Moving on to Section 2, the rules of greed and exactly why your intuition works. So why did that work so flawlessly? Let's look at Rule 1, the greedy choice property. This rule dictates that a local optimal choice mathematically guarantees a global optimum, and this brilliantly illustrates why our boardroom strategy worked out so perfectly. By greedily grabbing the meeting that ended earliest, we guaranteed we were leaving the maximum possible free time for all the subsequent meetings. We didn't need to look ahead and simulate all the other complex combinations. Just making the best, most selfish choice in that exact moment was enough to win. Now, the second requirement is optimal substructure. I know, kind of sounds like a mouthful, right? But actually, it simply means that the optimal global solution contains optimal solutions to smaller subproblems. Think of it literally like building a perfect brick wall. You can only build a perfect wall if every single row of bricks is also laid perfectly. If you pick the first optimal meeting for the boardroom, the remaining time in the day is really just a smaller version of the exact same scheduling problem. You can only use a greedy algorithm if your problem can be seamlessly broken down into these perfect, repeatable foundational pieces.
Okay, so say you think you have a greedy solution to a problem. How do you actually prove it so you aren't just guessing? Well, we've got two primary ways to mathematically verify your logic. Over on the left, we have the exchange argument. This is a formal proof where you show that swapping your greedy choice with any other possible choice simply doesn't improve the final result. If swapping makes the result worse or even keeps it exactly the same, your greedy choice is undeniably optimal. Then on the right, we have known patterns. For most developers actually in the trenches, just recognizing the problem type is the most practical way to go. Basically, if it smells like a classic greedy setup, it probably is.
And speaking of those known patterns, let's look at the undisputed champions. These are the classic coding challenges where the greedy approach completely dominates. First up, we have interval scheduling, which we just solved together. Remember, the trick is always to sort by end time. Next is the famous jump game, where your strategy is simply to track the maximum reachable index at every single step. And finally, Huffman Coding, which is a highly efficient data compression algorithm where you just repeatedly merge the two smallest frequencies. Seriously, memorize this list. If your next challenge looks like one of these champions, greed is almost certainly your best friend. Which brings us to Section 3, when greed fails, or as I like to call it, the trap. I kind of have to pull the rug out from under you here, because human intuition can sometimes lead you right off a cliff. Let's look at the classic coin change problem. On the left side, we have standard coin denominations, like your standard US coins, quarters, dimes, nickels, pennies. If I ask you for 30 cents, you greedily take the biggest coin first, right? A 25-cent quarter, then a 5-cent nickel. Boom, 2 coins, perfect. Greedy works. But look over at the right side.
What if we have arbitrary coin denominations? Let's say our fictional country has coins worth 1 cent, 3 cents, and 4 cents. If I ask for 6 cents, a greedy algorithm selfishly grabs the biggest coin first, a 4-cent coin. Then it needs 2 1-cent coins to finish the total. That's 3 coins total. But wait a second. 2 3-cent coins would make 6 cents using only 2 coins. The greedy algorithm just failed completely. This counterexample proves that the greedy choice property is totally broken here.
So what on earth do we do when we actually fall into this trap? Enter the heavy-duty backup plan. The rescue here is dynamic programming, often just called DP. When a counterexample exists, like those weird 3-cent and 4-cent coins, you have to abandon your greedy approach immediately. Dynamic programming is essentially an exhaustive, incredibly smart search. It meticulously checks all the overlapping subproblems to guarantee the absolute right answer when a simple greedy choice just can't. If greed is a quick sniper rifle, DP is a massive, inescapable net. When the sniper misses, you throw the net.
All right, Section 4, the ultimate action plan. This is basically your interview playbook. Let's get highly practical here. I really want you to burn this step-by-step playbook in your brain right now. Step 1, try greedy first. It's fast to think about and it's fast to write. Let your intuition speak. Step 2, think incredibly hard to find a counterexample. Seriously, play devil's advocate against yourself. Try out weird edge cases like our arbitrary coin denominations. Step 3, if no counterexample exists after really genuinely trying to break your own logic, confidently code the greedy solution. But step 4, if you find even one single counterexample, drop it immediately and pivot to dynamic programming. So the crucial point is this. Your success doesn't come from guessing greedy. It comes from actively trying to break your own greedy logic before you write a single line of code.
To truly master all of this, there's a fantastic piece of advice from the source material. Interval problems are the best practice for greedy. If you want to train your brain to instantly recognize these patterns, practice sorting intervals over and over again. Learn exactly what happens when you sort by start time versus sorting by end time. Honestly, once you deeply understand the nuances of interval scheduling, the entire greedy paradigm will just click right into place for you.
And that brings us to our final thought. In your next coding challenge, will your local choice beautifully build the perfect global solution, or are you just falling into the greedy trap? The next time you feel that overwhelming urge to just grab the biggest, fastest, or earliest option, I want you to remember the boardroom scheduling, remember those weird arbitrary coins, and really ask yourself, am I mathematically guaranteeing success, or am I just hoping? Thanks for joining me to unpack this explainer. Keep verifying those algorithms and keep learning.